Okay, so today we're going to talk about 6 gigahertz. So we announced a new product called the Bolt 6 at IBC this year. And so there's been a lot of questions as to what does that 6 mean. I think a lot of people have said, oh, it's 6K or it's 6th generation, but it actually refers to the spectrum that now we are able to offer to our customers because the FCC and compatible organizations around the world are now opening up this spectrum for us to use. And this is really exciting opportunity for our industry because it means we're going to move away from what's typically used with Wi-Fi and all the networks that are on set. You know, we have something new. Doesn't mean that we have to forget about those. We can still use those as options, but now we have something new and exciting that we can use. So the goal today is to talk about what that means, what 6 gigahertz entails, and how that applies to our products. So the first thing to talk about is, as I mentioned, our on-set experience is very crowded right now with lots of wireless technologies, from wireless lens control, camera control. Obviously, we're going to talk about wireless video, your mobile devices, wireless audio, DMX, wireless lighting, location Wi-Fi, and then everything else that's just around you when you're on location. So it's really crowded, and so that's what we're going to start to dive into, what the technologies are that are available and how it can work together. So I'm going to pass it over to Rafi to go through some really high technical information, and then we'll talk about the products, and then we'll talk about some best use cases and best scenarios for you to maximize your image quality and what you're using on set. So, Rafi?
Hi, nice meeting you. So like Greg said, I'm from Israel originally, from Amimon. We developed the chipset that is used utilized in the Bolt product family. And we took this opportunity to discuss a little bit about the technology, how it works in a very high level. If you have any questions, please let me know. I worked at Amimon for 14 years, managed the software development and the QA and everything, so it's very exciting for me to meet the guys that are using the system because we are very far from the industry in Israel. So first I want to explain about, there are two frequencies being used, unlicensed frequencies being used for video transmission, 2.4 and 5. There are more options. You can go to the lower bandwidth, but you don't have enough bandwidth over there. To the low frequencies, but you don't have enough bandwidth over there. If you go to the 60 gigahertz, then you have high bandwidth, but there's no penetration. If you move your hand, the signal will fail and will drop. So it's not very robust. It's only for point-to-point when you can guarantee that there is no interference or obstacle in between. So we have two options. One is 2.4 and 5 gigahertz. There are trade-offs and cons and pros. So the 2.4 is low bandwidth. It's very crowded, not many channels, so you can use them. And you saw that there are many systems. Most of the systems are using the 2.4 gigahertz. It has better optical penetration, but again, because you don't have enough channels, then you cannot have too many systems on these channels or on these frequencies. And we have the 5G. So 5G, we think, this is why Amimon picked frequencies. It's the best frequencies to use. It is less crowded, again, especially with the 6 gigahertz. And it still penetrates obstacles, right? It cannot penetrate concrete walls, very thick walls, but you can have a very robust and stable signal in indoor and outdoor. So this is like the best, we think, and this is why we pick these frequencies. Now, after we pick the frequencies, there are two main systems. So if we divide it like in a very high level, we divide the systems. We have Wi-Fi packet-based solutions, so they take the video, they encode it and stream it over Wi-Fi, or it can be Ethernet or others, but we are talking about wireless. And we are talking about Amimon technology, which is frame-based. It's not packet-based, and we will explain in a second what's the difference between the technologies and why Amimon technology actually fits the cinema market and the wireless products. Every wireless transmission system or any system, you have a transmitter, you have a receiver, right? You have the video encoder and video decoder. The video encoder takes pixels, raw video, and converts it to encoded bits. Then you need to stream it. And of course, the other side, the receiver, is like a mirror of the transmitter side. But you always, if you want it to be stable, right? There are two parameters. One is the capacity of the channel, right? How many bits you can stream in a robust way. and the R is the rate that you are transmitting. And you must keep always the rate below the capacity. Now the problem is that the C always changes. You see the capacity of the channel, and you see that there are drops, right? There are deep drops.
Someone walks by, the channel capacity can change, even though its maximum, is quite high.
Yeah, so this is the orientation of the antennas, it can be the range, it can be an obstacle that just came for a very short time. And now there are two options to cope with that. If you're taking a traditional Wi-Fi encoding system, this is a lower barrier, and you can just use lower rate, just below the minimum capacity that you think you will have.
So you're always safe. You're using a tiny chunk of the channel. Even with the worst hits, you're never going to experience interference. But you're also highly limited in the amount of data that you can send.
Quality and the bit rate, yeah. Another option is the upper barrier, and here you can cope with this drop by buffering the data. But if you buffer the data, of course, you will have latency. And if the drop is lower, then you need to buffer more. Then you don't have a constant latency in your system.
Just quickly, just explain what buffering is. Basically, you're sending frames, packets that contain frames, and then you get extra frames. So if you miss a frame, you can say, oh, that was that frame, put it into the spot. But now you have a delay, right? And you have to wait for the additional frames to come to keep your buffer fill.
Yeah, because the video must be always
and if you get too many hits, you run out of buffer, and then you can have a big drop in your video.
Yeah. So because video always must come out from the system, right? You cannot freeze it. You don't want to have a freeze. Then you need to buffer. It can be 2, 3, 4 frames. It depends how bad is the channel and how much you need to buffer to cope with these dips. And what Amimon is doing is actually following the channel all the time. We'll show you in the next slide how we are doing that. But we're always following the channel, so we always use whatever the channel gives us. We don't need to prepare for these dips. Our transmitter always transmits the same data, and the receiver will just get what it gets, and it will always get what the channel allows him to get, right? So we don't need to prepare, we don't need these buffers. How we are doing that is a technology called joint source channel coding. So we are splitting the data to layers. And we have the basic layer, which is audio and basic control information, headers, metadata that define the streams. Then we are also dividing the video to two levels. One level is the most significant video, we call it cores. And we see the cores is always below the drops in the capacity. So once we get the cores, everything is still running. It will work. Nothing will break. So the latency will not increase. And we're also sending another layer of video. We call it fine. And this is the least significant information of the video, right? So if in this momentary drop, you will just get a very, very short time of reduced quality. But it will not affect anything on the latency. We don't need to buffer. We don't need to wait. And it's so fast that you will probably won't notice that. Okay, so this is what our Amimon technology is doing. So the transmitter always sends these layers, right? The basic, the coarse video, and the fine video. And it doesn't care what the receiver is feeling, or what the receiver is getting, or what is the channel that each receiver getting, right? If you have different receivers, it doesn't need to interact with each of them and send different information or retransmit packets, right? Every receiver will cope with whatever it gets. This is very unique in the technology. So if you pick a very generic Wi-Fi based system, it will have delays. It can be, again, 2 to 4. You can configure that, or it depends in the system.
2 is very low. I mean,
two is very low. It's very hard to get 2. And again, it might work with 2 frames in a very good net channel, but in a bad channel, it will not be as robust as the Amimon technology that we just showed. It is compressed video, low bandwidth. Wi-Fi system can work both in 2.4 and 5. We discussed the differences and what you should use. And it is less robust. It is packet-based. You need to keep gap or buffer for to increase the latency, or for the drops to always have the rate below the capacity. And this is a summary of joint source channel coding, our Amimon technology. Again, it is zero latency. It has 1 millisecond latency actually. We need to buffer only one line of video. One line is 16 lines of pixels. Visually lossless. So again, we send the data, the video data in different layers, and we always get the best quality that you can. And we compress it in a very specific, unique way. We have dual modulation. This is the coarse and the fine that we mentioned. It works on 5 gigahertz, and now it also works on the 6. We will show it in a second. It has smart mechanism of picking the frequencies. And again, it is very robust comparing to other technologies and options in the market. So just to recap, not all bits are equal in Amimon system, right? Comparing to a data modem, we'll see it. The receiver is continuously using the channel capacity, and there is no need for retransmission and feedback from the receiver to the transmitter. In the Wi-Fi system, all the bits are identical in the importance, right? So if you can drop a packet that has the most important information of the video, and you don't know that because it's not protected in a different way, you must have margin or buffers for the channel capacity, and there are retransmission required if you want to have all the time the best quality. So you need to catch up. Yeah.
How is the system able to dynamically identify the channel capacity?
You mean the receiver? Amimon
The
technology?
transmitters.
In which channel?
It doesn't need to identify it because it sends the required information over this really robust, small capacity channel, and then it just sends all of the information over the rest of the available channel. So that's why it's uncompressed, because it's truly sending all of the bytes of video. I mean, you're sending all of the video information. And whether or not the channel takes hits, it's robust all the way down to this incredibly low bandwidth.
So it's not actually modulating the transmission with the channel capacity, it's
the
just
channel
throwing
itself.
it all out there, and what gets there, gets there.
We can compare that, one second, we can compare that to an analog system. In the past, you had analog systems, right? So there's no communication between the transmitter and the receiver, right? The receiver, whatever it gets, it can show you. So we stream the basic data of the video in a digital way. It is protected, and the receiver will get that. It is below the capacity of the drops in the capacity.
Obviously, if you put your transmitter in a lake, there's no channel, but it requires a low channel to operate with the required information.
So the coarse is the digital layer, and the fine that we call, it's a refinement. It just it's increased the quality. So as much as you will get better quality, right? So this is like very similar to analog system, right? So this again, what is unique in the technology is it's a combination of basic layer that it is very robust. You will get it all the time. You can still see video with that, and it is good.
Maybe just
but the fine will be perfect.
That it's actually happening, algorithmically in a piece of silicon that Amimon created. So it's that, and that's why it's able to be done with low power and a small form factor and with zero latency. Yeah.
This is again something unique because the encoder, the video encoder and the video modem are working, and the RF modem are working together. It's one silicon that does everything. So it can come with the video and with the network, and is doing everything together. When you build a Wi-Fi system, it usually you have an encoder, you have the Wi-Fi, which has the modem, the RF modem. So it's separate units and don't have the same.
And it's not designed for video, it's designed just for networking, right? So you're using that layer to send video through a network. This is designed specifically for point-to-point transmission on its own link.
So this, I just want to mention that there are systems in the market based on our technology, knockoffs. They are not regulated, they don't have certifications. The stream or the output power is more than you're allowed. They work in DFS frequencies, different frequencies that radars can work on, and you need to detect the radars or check that there are no radars before you jump to these frequencies. They are not doing that also, and they are using our patent. So, okay, so we discussed about the frequencies. Options 2.4 and 5. We discussed about the technology. Now we're just going to explain the frequencies. So why is the 6G is now introduced? So until now we have Uni 1, Uni 2, and Uni 2C. You see the Bolt system. These are the frequencies that were allowed until now by FCC, unlicensed frequencies. DFS required. You see most of the spectrum is requiring DFS mechanism. DFS again mechanism. You need to detect or scan for 1 minute that there are no radars in your frequency, and in a frequency that you want to hop on. And once you see that everything is clear, then you can jump to this frequency.
Yeah,
okay?
so that's the majority of the 5 gigahertz spectrum is governed by DFS. And to legally use it, to get the appropriate certification, you have to behave in this automatic way, which is a dynamic way where the systems listen to that channel. They can't join it for 60 seconds. They have to ensure that there's nothing, weather radar, airplanes, etc. In that channel, and then they can join it. So this is international regulations throughout the world. There's some idiosyncrasies to which channels different regions allow, but essentially all of DFS is regulated in this way. We talked about the illegal knockoffs. They use those channels without the legal listening and behavior, and so every time they're used, they're basically, a $500,000 fine could technically be issued for every day that they're used in those channels, which is to say why we don't do that. We have to make our stuff adhere to the rules of the road in all these different regions.
Yeah, so as Greg said, we are starting the link on a non-DFS channel, scan this DFS frequency for 1 minute, then we hop to a DFS frequency, and also then you need to keep scanning the frequency for radar signals. So if you find a radar signal, you need to hop to another DFS frequency or to a non-DFS frequencies. So now Uni 5 is also open.
Can I just add one thing quickly? Just as a high level, the unlicensed bands are for devices that you have, right? Every other channel is all the channels. It's actually a natural resource of our world. It's just Mother Nature, so to speak, and all of the governments of the world regulate all of these channels, and they specifically set them aside for different purposes, not for civilians to go and transmit on. There's very few chunks of the spectrum that are known as unlicensed, which means that anyone can use them. You don't really think about that you're like a transmitter, right? But every device that you have that has Bluetooth, Wi-Fi, your wireless toaster oven, those are all like intentionally transmitters now. And the governments of the world have these RF bodies, and they all have these treaties that set aside these little tiny chunks of the spectrum to be used by devices that you can just turn on, like this computer. I'm not like signing up for a permit to connect to Wi-Fi. It's because Wi-Fi is using unlicensed spectrum. But as more and more and more stuff starts using Wi-Fi and connectivity, the spectrum fills up. So what's recently happened is the new unlicensed network unlicensed network interface something, whatever UNI stands for, is this new chunk of spectrum from 5.9 to 6.5 essentially, and that's what Bolt 6 uses. It's this new 6 gigahertz chunk of unlicensed spectrum.
This is a very big chunk of frequencies that were added to the system, and it opens a lot of options, or many options to use the system. So you can see now that for now you have 13 frequencies, 13 bands that you can use for a 40 megahertz channel and 27 for 20 megahertz channel. And now with the Bolt 6, which can use the Uni 5, you have 25 and 52. So it's doubling the number of frequencies, the number of channels that you can use, and the number of systems that you can use in parallel in a multi-system environment.
So I could have 52 cameras running?
Yeah, guaranteed.
You do that? 8K, don't use that one.
Lose my number.
No, the recommendation, we'll discuss it later, you should have a band free between two systems. So this is the recommendation. But it depends on the constellation and how you spread the cameras.
So it's technically a channel, but we're going half channel, half channel, half channel. So there's more channels, but these effectively we say there's about 12 new channels in our 40 megahertz transmission scheme.
Yeah. So we still keep of course the 5G for compatibility, and also 5G has also its advantages. It still has a longer range than the 6 gigahertz. In the 6 gigahertz, as you go high in the frequencies, the signal is a little less robust, but it still can get a nice range. This graph shows, it's from our spectrum analyzer. It shows the power that we measure on the channel, the signal strength that we measure. And we are showing you that the 5 gigahertz is very crowded. If you use the spectrum analyzer, you will see that many of the channels are already used. But if you go to 6 gigahertz, it's very clean. Systems are not using that yet. So we are the first to use this spectrum and frequency range. So it will be much clearer. So you can use it in a more robust way. The Uni 5 spectrum is now open in the USA and Canada. And it's coming soon. So we are getting always more feedbacks and updates on other regions that are going to allow that. So you can see a list of other regions and other countries that are going to allow. They will follow the FCC regulation, and we'll have that soon.
Yeah, our understanding is that the top ones are coming Q1. Yeah, one last thing. People see this Bolt 6 and they say, oh, it's Wi-Fi 6. It's not the same thing. Wi-Fi 6 is just the latest 802.11ax generation of Wi-Fi. That doesn't specify the channels that it's using, at least as my understanding.
I think it also
does. So it is not including Uni 5. It's the 5 gigahertz. It's the 5 gig and 2.4 gig Wi-Fi. Uni 5 is the new channels, as we just showed. Okay.
So they have. So the Wi-Fi organization has a new moniker called Wi-Fi 6E, and that actually extends into.
60 is Uni 5. Okay.
Yeah, into the Uni 5 band.
So no one used that.
Well, we can expect it to fill up. I mean, Apple starts selling. I mean, all computers.
It definitely. I mean, it takes. Look, the Bolt is ubiquitous, right? I know that, and it never has any problems anywhere in 5 gigahertz. Just kidding. Lots of people use it with a lot of success. Obviously, I think in the last year or two, it's started to become more and more of a challenge. With all the lighting guys crowding the channels, all the production just buys some, whatever the most expensive Wi-Fi router is. Video Assist has their own private network for their stuff. Sound has a network. There's just not so many channels left in 5 gigahertz. But that took when we started 10 plus years ago, it was a lot less crowded. I mean, and when Amimon started, 15 years ago, there was nothing in 5 gigahertz. Things were just starting to use 2.4 gigahertz. So it takes quite a while for the cost of the new radio systems to come down, that they just start going in every single device. They're just starting now. So we feel like there's going to be quite a long time where those channels are not totally polluted. And it's a good thing to remember that people still using Bolt on every single production, it's not like it just doesn't work. Now, people have horrible days where they just are having problems and they want to throw everything in the river. What they should do is go turn off all the Wi-Fi and then it'll work better. But when you have these two whole chunks of channels, you can still use 5 gigahertz on some and 6 gigahertz on others. You have a lot more environment to play in this natural resource.
But that's a great lead into this next slide, which is solutions we have in Bolt to find the right channel.
So the Bolt system has, you can use a fixed frequency, but the Bolt system has inherently inside AFS, we call it, an automatic frequency selection. So the transmitter will always pick the best frequency, the most quiet channel, and we start transmission on that, and the receiver will always find the transmitter that it is paired to. So the systems will always pick the best frequencies. This is one mechanism that we have. Another one, as we discussed, we have the DFS, the dynamic frequency selection, so we can utilize and use the DFS frequencies. So it opens
legally,
yeah. So it opens a big chunk of frequencies. And we also have an active image monitoring. So even after we pick the channel and we are working on that, the AFS mechanism is keep working and keep sensing all the time the environment and the channels. And if there is an issue with the video, the receiver will detect that and it will tell the transmitter, let's opt to another frequency. This frequency is not good for me. Sometimes the frequency can be good to the transmitter and not to the receiver. So the receiver can tell the transmitter, send him a message telling him, I have a problem in this frequency, let's hop to another clean frequency. So it will improve the frequency by doing that, and of course the video reception.
Cool. So with all that in mind, at IBC we introduced Bolt 6, and our primary purpose of this new product was to introduce the 6 gigahertz. What we've done is we're replacing the full Bolt 4K lineup. So that includes the Bolt 6 XT, the Bolt 6 LT, and the Bolt 6 monitor modules, as well as the Bolt 6 LT HDMI, which is an HDMI-only solution that we offer. So our full lineup will now be 6 gigahertz. It does keep all compatibility with Bolt 4K, so it uses our same BB3 chip, which the BB3 chip, separate from Amimon chip, is all about the sort of the workhorse and the power of the unit. So we felt like in order to get us to 4K, we needed this new BB3 chip, and that's why there was a disconnect between our Bolt 3000 and the Bolt 4K. But with the Bolt 6, same BB3 chip, we're just adding the addition of the 6 gigahertz. So the Bolt 4K and Bolt 6 are fully compatible in 5 gigahertz mode. Obviously, the Bolt 4K doesn't have 6 gigahertz, but you can mix and match in that respect. We also introduced a new algorithm to improve long-range image quality. And then we added some new tools, which we'll go through. For example, the SDI pattern tool, which lets you check your cable. So in case there's an issue, it's all about troubleshooting and seeing, okay, my image quality is not great, why is it not great? And sort of going through a checklist of what the issues are. So we'll talk about that in a minute. And then, so we saw this slide. We have the 12 new frequencies. But of course, you can still use all the 5 gigahertz frequencies. So with Bolt 6, we do have new antennas because we do need to make sure that our antennas are covering the full range of what our products are offering. So there's a new flexible H antenna, which is here, which is something that is a separate product that people have been asking for, is to have a flexible antenna. So it's not going to break. Some people were concerned the H antennas were breaking. So that's also brand new. And really nice.
I'm sure people here can figure out how to break it.
Yeah. Well, we'll see. You'll let us know. So that's super cool, but we do need a new H antenna and then the new V antennas that cover that 4.9 to 7.3 gigahertz. Now our array antenna, which is this guy over here, we came out with a version 2 of the Bolt 4K array antenna, and that actually we were kind of thinking ahead, and so that does cover to 7.3 gigahertz.
And so do the H antennas, the old ones, by the way. But
so now we're going to talk about some best practices. Here's some bullet points of how you can troubleshoot when you're on set. So first we want to just talk about what are the signs of disruption, right? We all know video blocking, kind of a pixelization of your images. We have obviously the signal breaking up and the signal completely dropping out. So how can we fix that? So first thing on the checklist is to create a clear path. It's important that the devices aren't super close to each other, and if there's any physical interference based on how you're mounting the device to the camera, it's always best to have line of sight, but we know that's not always possible. Using other devices that are these knockoff devices that Rafi talked about can cause overpowering issues between the devices. We often call that frequency polluters. Also, environmental effects, humidity, being underwater, is that you must have a specific
water
story.
Attenuates all of the frequency. So if it's raining, or you're in like a jungle, or you've dropped your camera in the lake, all of those things will limit your ability to transmit.
And then any other electromagnetic interference that's based in your area, obviously. So that can be caused by poorly shielded electronics or broken BNC cables, which we talked about. We have a new tool that lets you actually check the quality of your cable. So you can quickly see, okay, is it my cable that's causing this issue?
A lot of times you'll just have this mysterious interference, like people will say, oh, your transmitter is, spewing interference on a lower frequency, but that often is caused by like a badly shielded cable that has a harmonic interference. So if an SDI cable is damaged, it can turn itself into an antenna that's just dumping RF across the spectrum, and that can cause an HDMI cable. Could be the same thing because it's high frequency signal, and if it's broken, it can actually be amplifying it and causing interference. we've seen this all the time. You swap out bad cable, right? And the same thing could be for other devices. There are rules. Anytime you have electronics, you see like on your electronic baby pacifier, it has a FCC license on it. It's because it has electronics in it. So even though it's not a transmitter necessarily, if it has bad shielding, it can be dumping interference across the spectrum. Then also things that do have intentional transmitters, like a walkie-talkie. I've definitely seen someone holding a walkie-talkie next to a monitor, and when they transmit the walkie-talkie, the monitor turns off because something has bad shielding in that situation. So don't always blame us, is what I'm trying to say.
I'm hoping if James says, no, you don't have a bad cable, okay. I was hoping we had maybe a bad cable, you could come up, play with it, but you can still do it with whatever cables.
Are you designing your own cables or BNCs?
I mean, we design them. We design everything. Antennas, cables, everything is that we make is tested and validated. Obviously, you can't require everybody to use anything that you want them to. But there's good cables, there's bad cables, there's good antennas, there's bad antennas. Just because an antenna has a black plastic cover doesn't mean that it's the same as another one that you would buy on eBay for 1,000 for $1.
So let's talk about antennas, antenna position and the types of antennas. So we offer, obviously we just mentioned the H antennas and the V antennas, and then the array antenna.
One important thing is that it doesn't require line of sight. There's certain technologies that actually do require absolute line of sight, like the 60 gigahertz that Rafi mentioned earlier. Our scheme uses multi-path reflection, so it actually is often better to be in a room with ceilings or a hallway or a way to reflect the transmission around. However, it's even better to have zero obstruction in between the transmitter and the receiver. So ideally, you try to mount your receivers where it has direct line of sight to the transmitter, and the higher on the camera that you can get your transmitter, the better. Like I said, forests, trees, plants, human beings, water, bags of water. Water absorbs the signal. So the less of that you have in your way, the better. Just because you're in a forest scene, you're not that far away. You have a bunch of trees that's just going to suck up all the RF. It's not going to reflect it as effectively as if you were in a castle hallway or something. I've been doing this for quite a long time, not as long as Rafi, but when we started Paralinks, we've been dealing with seeing people that have their transmitter underneath their Steadicam pointing down. Don't do that. Don't have it vertical or horizontal either, because the way that the pattern is transmitted is like a giant donut. So when it's like this, it's like half of it's going into the ground and the other half is going into outer space.
This is the worst. Pointing.
Yeah.
This is the worst.
And the design for the transmission scheme is actually it's an orthogonal transmission, and you want to have everything straight up ideally. So please spread the gospel of vertical antenna orientation.
And if you
it will help.
If you do need to mount your device differently, adjust the antennas to
vertical. Always vertical.
Yeah.
Now, obviously, it'll still work, and your mileage may vary, but don't blame us when it's like 5 foot of range.
So let's talk briefly about what the difference is between the H and the V antennas. So the H and V stand for horizontal and vertical polarization. So they both have that same donut shape spread of the frequencies, but the polarization is vertical and horizontal. And so what this allows each one to do is kind of achieve a different level of...
Rafi, can you explain how that helps with the MIMO? Can you give a shot?
Yeah, so in the MIMO, there are 4 transmitting antennas and 5 receiving antennas. And what the receiver does is get equations. So you get equation for each antenna, for each transmitting antenna. He has 5 equations, right? And then he needs to get the signal from the transmitting, the video from the transmitting signal. If you go, for example, outdoor, then if you're indoor, right, then all the equations are different because they're going, each transmitting antenna or each receiving antenna actually gets a signal from a different path through the room, from the ceiling, through the walls, then it's easier for the system to get the video part from the transmission signal. But if you go outside, and it's outdoor, then you don't have reflections from the walls and the ceiling. So all the equations are very similar to each other. Then it's hard for the receiver to get the information from the transmitting antennas or signals. And what the polarity does, it changes, again, it creates differences between a signal that was streamed from a vertical or from a horizontal antenna. And then it helps the receiver to understand and take their video signal from the transmitter.
Because it might think that two of the transmitting antennas, it might actually think they're the same and therefore have like a lower quality, right?
If it's outdoor, then it will be they will be the same. They will be very similar.
Yeah. So by making one H and one V, you can tell them apart, which gives it a better chance of making a higher image quality on the receive
you create
side.
a MIMO again, so a different signal for each antenna.
It's
So
more,
really,
it's more better.
You always want to have the H and V. We only include the H and V. We're actually now including it in all the Macs and all the 1500 kits. Before we only did the Macs, but ultimately you'd love to just have them on any range kit. But the H can be a little more expensive, so we don't include those in the cheaper kits.
Yeah, and we design and make all these antennas ourselves. They're not really available generically because it is a very specific thing to our system.
What are the benefits of linear polarized antennas over circular polarized antennas?
I think I'm not an expert on antenna performance. I think in my own kind of caveman testing, we've seen very similar performance in terms of range and in quality. I think the way in which the transmission reflects off of environments could theoretically be different from a circular versus a linear polarized antenna. But for our system, we kind of figure out an optimal solution. We specify the fidelity of the antenna, we test it, we certify everything with these specific antennas. So again, this saying, right? Your mileage may vary. You could do whatever you want with your thing after you buy it. I don't know what the rules of your RF jurisdiction is, but I don't know if there's anything more we could say really circular versus linear.
So the antennas are a very important part of the system, and we test that a lot, and we check, and sometimes you get antenna that looks very similar, and they have a very different performance. And even when we get a new batch from the same supplier, we get different performance. So we always check that and verify that the antennas are working well, because it can just ruin the transmission.
It's kind of like a speaker or like an instrument where it has to play, the signal has to have the fidelity to play, a tuning fork, right? Like it has to sound correct, it has to transmit correctly. Just because the outside of it is plastic, black plastic, doesn't mean that all the inside, strings, so to speak, are correct, are good.
Yeah, it looks very similar, but the performance-wise, it can have a big difference between antennas, even when they look the same. It's very important. So the V and the H, again, it changes the signal, so you can get the fine stream that we just mentioned. It's transmitted on a V on an H. If they're transmitting on two different antennas, then the receiver can get the best quality from the stream. If you're using the same antenna, then it becomes the same stream, again in the equation, and it's hard to get the best quality. So HV is for best quality, but you get a little bit less dB or transmission power on that. But if you care only about range, you can use only vertical.
It's possible that just using vertical might get you slightly more range,
but it's just in the end.
But that's talking thousands of feet range. Yeah. So by the time you're in that, if you're trying to go on a drone, maybe don't use the H antennas. But then again, it might be better.
Don't do walls and stuff. Use the H and V.
Honestly, just use the H&V for almost any environment.
Unless you're in the end of the range, you need the system to work in 3 kilometers. You should use H&V to get the best quality. You get the best fine stream, again, that you mentioned.
And to be clear, all of our units are marked where you need to put the H&V antennas if that's unclear.
Does this go to 5,000 feet, these two?
Yeah, so with Uni 5, it has a requirement of having a lower transmission power. So it's like 20% less maximum range, I would say, if you're inside a massive, convention hall that went 5,000 feet. I think we're testing it and it's looking like 3,500, 4,000 feet. It's far. You could still achieve those longer ranges with the 5 gigahertz mode. Just switch to 5 gigahertz mode.
And then one other thing that I've had people ask is, a lot of people want the really stubby antennas, and there's a variety on Amazon, but I've found that most of those are only for a specific
5.8.
5.8 frequency.
It's the same thing what
So
Rafi said, right?
you're cutting your...
So with those, they have one channel that they're tuned to transmit. They can be like told to play other tunes. But the same, this is a dumb caveman analogy, but like when you try to play high, a glockenspiel on a subwoofer, you might get some rattle, but it will, that's hyperbolic, but it will transmit on those channels probably, but it doesn't do it cleanly or to the specification. So the range will be worse, the video quality will be worse if it works at all.
Yeah, right. Usually the 5.8 antennas work only on 5.8 and 5.9, and our system works between 5 and 6, and now 6.4. So you might start on a non-DFS 5.8 frequency, and then our system will jump to a DFS frequency, which is not in the spectrum of the antenna, and then the signal will just drop. So again, it's better to use the supplied antennas that were tested and verified.
Cool. So the next thing to talk about is our array antenna. So the H&V antennas are both omnidirectional, right? They're that donut shape, sending signal out all directions. The array antenna is a directional antenna. So this is your front of your antenna, and so you're going to point this directly at your receiver, and this can help maximize range.
It's
and
kind of like
that
cupping your ears, so it doesn't have higher gain. It's just focusing the listening aspect.
And I think that is a misconception that this is just more powerful. It's meant to direct where you're looking for that signal.
And then the little antenna that sticks up, we used to have one of the antennas, because it's an antenna with multiple antennas and different polarization on this big circuit board inside of it. One of them used to be an omnidirectional antenna, so it's listening all the way around, but the back of the antenna is metal. So we changed the design to now have it just an omnidirectional antenna that sticks up. The way that would be useful is if your Steadicam operator happened to or your camera happened to go outside of the pattern of the cone of the antenna, and you just will get, or the multi-path reflections bouncing off a wall behind you, just improve the overall performance, but it shouldn't affect range.
So now let's talk about channel management. We offer the Bolt Manager app. If you want to download it now, you're welcome to. But within the app, we offer a spectrum analyzer. So you can yourself see what those frequencies are that are around you and what to choose as you're selecting your frequencies, either letting the system do it, or we'll show in a minute, you can go into a fixed frequency and you can actually choose, I only want to stay on this particular frequency because there's nothing else on that frequency. With Bolt 6, we definitely will recommend starting with 6 gigahertz. That's probably going to be the channel with less interference. But like we did talk about, 5 gigahertz can give you a further range. So if that's important, it's important to go ahead and switch. Then we talk about channel bandwidth. So for both 6 gigahertz and 5 gigahertz, we have a 40 and a 20 megahertz bandwidth. So the 40 is 12 channels, 12 options that you can choose from. And what we're doing is we're bonding 2 different megahertz channels to give you a wider pipeline. And so that's going to give you more flexibility, keeping your signal strong. But it does mean that it might be more susceptible to interference. And so the 20 megahertz channel, there's 24 of them because they're narrower pipeline, but it will obviously avoid interference because it's narrower. So these are just tools, and there's not necessarily a right or wrong way, just things to think about as you're trying to solve this puzzle of how do I maximize my image quality. Up until now, we assumed you're on automatic frequency adjustment, but we can also switch to fixed frequency, and so you can pick which channel you'd like to stay to. And then finally, we offer some image quality adjustments. So these are kind of algorithms that we've defined to help keep the image as the best quality as possible. So first you have auto, where the system will pick one of these options for you based on its understanding of the image. Then there's long distance, which is best for outdoor use. Then there's two different qualities of best quality, which is mid-range and short-range. This is for inside use, especially with Wi-Fi networks that are around you. This is going to keep the quality best there. And then there's the low power option, which we designed specifically because we've heard that a lot of directors stand right next to their camera with their wireless handset, and so the power between that short distance is just too much, and so you're going to lose signal. And so we have low power mode that's going to just lower that power and then have a better image quality for them standing right next to it. So
We're working on actually improving that so that does it automatically as well. So, because it's really not optimal to have to change a director's monitor to a higher or lower power level.
Definition of a short distance.
6 feet.
super close, like right here. Yeah.
And it's not always happening, but sometimes it can just saturate the receiver antenna and cause it to break up.
So that's pretty much it. Basically, again, this is all just a puzzle that you're trying to solve. How do I get the best image quality based on my surroundings? And so using these tools and figuring out what works best in your situation is what you have to do.
Yeah, and mainly the differences are the Bolt 6 XT is able to transmit or ingest and output 12 GSDI, so 4K transmission, P60, and then the LT, it uses the same scheme and the same chipset, but it is limited to 3 GSDI, so it transmits HD. You can transmit UHD P30 over HDMI. It's not optimal for most people to use HDMI, but the electronics inside can do that. And that's really the kind of two main families. They can interface with each other, so if you have a bunch of XTs and you want to add an LT receiver to it for like a director's finder, additional monitor, it will receive the 4K transmission from the XT and output HD. It doesn't like require all of the transmitters to drop down to HD transmission. And then vice versa, if you have a big LT system and you happen to need an extra receiver, you have an extra XT receiver, it's still only going to be receiving HD, so it will output HD. And the XT systems, it has scaling capabilities as well. So if you're receiving an HD signal but you want to output 4K, you can scale up and output 4K out of the receivers. Vice versa, you can also downscale in case you have a HD monitor and you want to output HD even though one of your receivers even though all of your system is receiving 4K, you can select it on the receiver itself or using the app to choose what resolution and frame rate you output.
And then one other thing for Bolt 6 specifically, the XT we've redesigned. So compared to Bolt 4K, the XT-TX is slightly smaller, and it has a new heat management system. So it's going to run cooler, and the fan will be a little quieter. So that's the other benefit of Bolt 6.
Could that fan potentially be blocked by roll-down and remount plates?
No, it's designed to go out of the vents. There's vents on our plate, so it's designed to work that way, yeah.
Other questions, thoughts?
Lots of electricity going through
The
it.
60 gigahertz only works in the US at the moment, but if you take it overseas, it still works, right? It's just
No way to know.
technically. What?
Yeah, you'd have to check. You'd have to check with your local authorities as to what the rules of that area are. But our understanding, we've heard they're going to open it in January. I heard that. I mean, no guarantee, it's up to them, but that was the last we heard, so.
You're saying the Amimon transmission, what bolt generations that goes back to? Like, have you been using that same?
Every bolt. Yeah, so the newest chipset is like, it's quite a phenomenal piece of technology. It's our own chip that is manufactured to the specification of the technology. It's all patented. It won some SciTech awards and stuff. I mean, it is a totally unique thing, and it's also a unique piece of electronics, similar to like a sensor wafer, right? It's our design, and the previous generation, it started, as something that the founders of the company wanted to put in every single laptop computer to mirror their display without a cable to a TV or to a projector. And the idea was that it would be, this thing just like a modem or a Wi-Fi card in every single device. That didn't work out that way because, we got ARM processors in every television, and you can buy a Google Chrome stick for $10 that can stream video from the internet. So what we figured out how awesome it was to have low latency or zero latency uncompressed video for our critical monitoring. And so we adopted the second generation chip, with Amimon years and years ago. And then when Bolt 4K came out, that was the first use of the 4K chip, which is an evolution from the original technology. Which is what we're using now. But the bolts, the HD bolts from like Bolt Pro all the way through Bolt XT and LT, like the 500, 1000, 3000, those are all on BB2, baseband 2, and now we're on baseband 3, which we keep iterating on with our own team in Israel and the team in California working together.
Yes.
So if you have the Bolt 6 XT and you're using 4K, if you switch to HD, are you going to get longer range?
No.
No, it would be the same.
I mean, you could theoretically you could go to 20 megahertz channels and find a slice of the spectrum that is in a really crowded environment that's not polluted with other stuff. I mean, that would be something that you could do, but it wouldn't boost your range.
Well, I guess that makes me think. So if you had the choice of 6 or 5, because you have one of those, and you're in a house, I film in houses. Which would you prefer? If all things were equal, would you get better wall penetration with the 5 gigahertz?
No, we just say use the 6. I mean, the fact that there's nothing in that environment right now, it's just going to be better. If you're like specifically trying to punch through something like the slightly higher transmission power of the 5 gigahertz, I don't think it really is noticeable unless you're like on a beach and you're trying to see how far you can go.
When we're talking about the lower transmission power for the 6 gigahertz frequencies, is that specifically a limitation on the Macs and their transmission power, or is it across the board everything is just less?
It's the requirement for Uni 5. It has a lot of specifications, and one of them is that it has a lower dB, 2 dB less than the other ones, which is why we specified that gain of antenna, with that frequency on it, and it's installed, so we adhere to the rules of that.
Cool. Well, thank you guys. Appreciate it.